Hey, welcome back. I'm David, and this is the show where we take science seriously, but never boringly. Before we dive in, I want to ask you something. Right now, wherever you're sitting, on your couch, in your car, maybe on a train somewhere in Europe, or walking through a city in the States, I want you to feel the surface beneath your feet. Solid, right? Real. You can feel it. Here's the thing, you're not actually touching it. Not even a little bit. The electrons in your shoes and the electrons in the floor are repelling each other so powerfully that you never make physical contact. You are, at this very moment, hovering. Welcome to science, where the truth is always stranger than fiction. Today, we're covering 5 science facts that sound absolutely made up, but are backed by Nobel Prizes, peer-reviewed research, and some of the most brilliant minds in human history. Let's go. All right. Segment 1. Time. You probably think of time as this steady, reliable thing, like a river flowing at the same pace for everyone. Monday comes after Sunday. An hour is an hour. Simple. Einstein looked at that idea and said, absolutely not. In 1905, Einstein published his special theory of relativity. The core idea: time is not constant. It bends, it stretches, it slows down and speeds up depending on 2 things: how fast you're moving and how strong the gravitational field around you is. This is called time dilation. Now here's where it stops being textbook physics and starts being your actual life. NASA's GPS satellites are orbiting Earth at roughly 14,000 kilometers per hour. Because of their speed, time for those satellites runs about 7 microseconds slower per day than it does for us on the ground. But here's the twist. Because they're farther from Earth, gravity is weaker up there, and weaker gravity makes time run faster. That adds about 45 microseconds per day. Net result? Satellite clocks gain roughly 38 microseconds every single day, compared to clocks on Earth, 38 microseconds. Sounds tiny, right? If engineers didn't correct for this, every single day, your GPS would drift by about 11 kilometers. You'd ask Google Maps to take you to the nearest coffee shop and end up in a different city. Einstein's theory isn't just a thought experiment. It's running in the background of your smartphone right now. And here's an unknown fact that I love. People who live at higher altitudes age slightly faster than people at sea level. Because gravity is weaker up high, time moves fractionally quicker for them. It's an unbelievably small difference, but it's real. It's been measured. Mount Everest climbers, technically, are aging slightly faster at the summit than everyone at base camp. Time is not what we think it is, and that's just the warm-up. Segment 2. Quantum mechanics. This is the branch of physics that deals with the very, very small atoms, electrons, photons. And it is, without exaggeration, the most successful and most disturbing theory in the history of science. Successful because it underpins almost every piece of modern technology: lasers, MRI machines, computer chips, solar panels. Disturbing because it tells us that at the fundamental level, reality doesn't actually exist until you look at it. Let me say that again. Reality doesn't exist until you observe it. This is called the superposition principle. A particle doesn't have a definite position, or speed, or state, until the act of measurement forces it to choose. Before that, it exists in all possible states simultaneously. This isn't philosophy. This is experimentally verified physics. Erwin Schrödinger, one of the founders of quantum mechanics, was so frustrated by this idea that he invented a thought experiment to show how absurd it seemed. You've probably heard of Schrödinger's cat. Imagine a cat in a sealed box. Inside the box is a quantum particle, say a radioactive atom, that has a 50-50 chance of decaying. If it decays, it triggers a mechanism that releases poison. If it doesn't, the cat lives. According to quantum mechanics, until you open the box and observe what happened, the atom is in superposition. It has both decayed and not decayed, which means the cat is, technically, both alive and dead at the same time. Schrödinger intended this as a reductio ad absurdum, a way of showing quantum mechanics couldn't be right. But here's the jaw-dropping part. He was wrong. The math holds. The experiments confirm it. Reality at the quantum level genuinely behaves this way. And right now, engineers are building quantum computers that exploit this property. Instead of processing in binary, ones and zeros, quantum computers process in superpositions of ones and zeros simultaneously. The implications? A sufficiently powerful quantum computer could crack today's most advanced encryption in seconds. It could simulate molecular behavior to design drugs we can't even imagine. It could solve optimization problems that would take today's best supercomputers longer than the age of the universe. We are building machines that run on the logic of a reality that still confuses us. Okay, I'll let you breathe for a second, because what comes next involves you personally. Segment 3, the human brain. Quick question, who's making your decisions? You, right? Consciously, deliberately. You think it through? You decide? You act? Well, about that. In 2008, a team of neuroscientists at the Max Planck Institute in Germany ran a now famous experiment. They put participants in a brain scanner and asked them to press a button whenever they felt like it, completely freely, at any time of their choosing. Using the brain scans, the scientists could predict which button the participant would press and when, up to 7 to 10 seconds before the participant was even conscious of having made a decision. 7 to 10 seconds. Your brain commits to a course of action nearly a full 10 seconds before your conscious mind thinks it's made the choice. This builds on earlier work by neuroscientist Benjamin Libet in the 1980s, now called the Libet experiment, which showed that brain activity precedes conscious awareness of a decision by about half a second. The question this raises, and philosophers and neuroscientists are still fighting about it, is whether free will, as we understand it, is something of an illusion. Now, I'm not here to tell you that you're a robot. The science is genuinely contested, and there are strong arguments on both sides. But the idea that your conscious you is the sole author of your decisions? That's looking increasingly complicated. Here's another unknown brain fact that I find staggering. Your brain receives approximately 11 million bits of information per second from your senses. How much does it consciously process? Around 40 to 50 bits. Everything else gets filtered out, which means the world you are experiencing right now, the room around you, the sounds you're hearing, this very conversation is not reality. It is your brain's edited, compressed, best guess reconstruction of reality. You are not watching the world. You are watching your brain's movie about the world. And one more, your brain contains roughly 86 billion neurons. The number of possible connections between those neurons is greater than the number of atoms in the observable universe. The most complex known object in existence is sitting in your skull right now, and it's telling you you're not interesting enough. Ignore it. It's biased. Segment 4. The universe. Let's get some perspective. Space is big. You probably know that. But let me give you a number that reframes it completely. If you took the entire observable universe and calculated what percentage of it could support human life, the answer would be something like 0.0001%. Everything else? Too hot, too cold, too radioactive, vacuum, crushing pressure, lethal radiation. The universe, by default, is completely hostile to life as we know it. And yet, here you are. Here's why that's so improbable. It borders on the miraculous. Earth sits in what astronomers call the Goldilocks zone, the narrow band around a star where liquid water can exist. Not too hot, not too cold, just right. But that's the least of it. Jupiter, the giant planet in our solar system, acts as a gravitational shield. Its enormous mass attracts and absorbs asteroids and comets that would otherwise head toward Earth. Without Jupiter, we'd be hit by catastrophic impacts far more frequently. Life probably couldn't have stabilized enough to get complex. Earth's magnetic field deflects lethal solar radiation that would otherwise strip our atmosphere and irradiate the surface. Our moon, unusually large for a moon relative to its planet, stabilizes Earth's axial tilt. Without it, our seasons and climate would swing wildly over millennia, making stable ecosystems nearly impossible. Remove any one of these factors, and the story of complex life on Earth probably never happens. Now here's an unknown fact that absolutely broke me when I first heard it. The light hitting your face right now left the surface of the sun about 8 minutes and 20 seconds ago. That we know. But how long did it take that same light to travel from the core of the sun to the surface. Between 10,000 and 170,000 years, photons generated in the sun's core bounce around in the dense plasma, getting absorbed and re-emitted millions of times before they finally escape. The journey from the core to the surface, a distance of about 700,000 kilometers, takes longer than human civilization has existed. The sunlight in your window today began its journey when Homo sapiens were still sharing the planet with Neanderthals. Fifth and final segment, and this one is my favorite. Let's talk about what you're made of. Your body contains hydrogen, carbon, oxygen, nitrogen, calcium, iron, and dozens of other elements. You learned this in school, nothing new. But where did those elements come from? Hydrogen formed in the first few minutes after the Big Bang. Simple enough. But heavier elements, carbon, oxygen, nitrogen, iron, those can only be forged in one place, the cores of massive stars. Stars spend millions of years fusing lighter elements into heavier ones through nuclear fusion. When a large star reaches the end of its life, it explodes in a cataclysmic event called a supernova, one of the most violent events in the universe. That explosion scatters all those heavy elements, carbon, oxygen, iron, out into space. Over millions of years, that material drifts through the galaxy. It clumps together under gravity. It forms clouds, then disks, then new solar systems, then planets, then, under the right conditions, life. The iron in your blood right now was forged in the heart of a dying star that exploded billions of years before our sun even formed. Astrophysicist Neil deGrasse Tyson has a line I keep coming back to. We are all stardust. It sounds like a bumper sticker. It is, in fact, astrophysics. You're not a person living in the universe. You are the universe, temporarily organized into the shape of a person, having thoughts about itself. Take a breath and sit with that for a second. All right, let's bring it home. Today, we covered 5 science facts that should fundamentally change how you see reality. 1. Time is not constant. It bends with speed and gravity, and your GPS is proof. 2. At the quantum level, reality doesn't exist until it's observed, and we're building computers that run on that logic. 3. Your conscious mind may be more of a narrator than a decision maker, and the world you experience is your brain's edited version of reality. 4. The universe is almost entirely lethal, and the conditions that allow you to exist are so precise they're almost impossible. 5. Every atom in your body was forged in stellar explosions billions of years ago. You are, literally, made of stars. Here's what I want to leave you with. Science isn't a collection of cold, dry facts. It's the most profound story ever told. And the most remarkable part is that you're in it. The next episode, we're going into dark matter, the invisible substance that makes up 85% of the universe's mass that we've never seen, never touched, never directly detected, but know with certainty is there. If you enjoyed this episode, share it with someone who thinks science is boring. Let's fix that together. I'm David. Thank you for listening. Stay curious,